Hello, I am Tariq, a senior electrical engineer. In this presentation, I'm going to present my project, math371 project. The title of my project is denoise images. The object of the project is to denoise images using neural network fitting. The tools I used in this project is MATLAB Live Editor, MATLAB Deep Learning Toolbox, pre-trained denoising convolutional neural network. The shortcut of this name of this function is DnCNN. Also I used two function denoising network and denoise image. To present the project, I used Wix website editor, as we can see. Also I used imShowPair function to compare the differences between images, as we will see later. Here is the math representation of the noise. Bx represents the noisy picture, which equal ux, which represent the original picture plus the noise, the added noise. X is specific pixels from the picture, and this represents the collective of picture, all pixels of the picture. In most application, we have Gaussian noise, which generally happens in the analog signal in the electronical of the camera. We can use the previous mathematical representation to represent the Gaussian noise. Y represent the noisy picture. I is the original plus the Gaussian distribution coefficient multiplied by the constant. Why we are using Gaussian noise to have some sides of the noise we are going to face. Here is the function of the coefficient of Gaussian noise, two-dimensional Gaussian kernels. We can see this function. U is the original picture and V is the noise. No, V is the noisy picture. If we use this function to find the coefficients of the picture, we will have a smooth picture, but we didn't use this. I didn't use this procedure in my project because I used DnCNN function. We can see this here we are zooming in part of the picture. Each square represents a pixel, we can see that in the middle we have the maximum coefficient, and it will decrease as we go away from the center. Okay, here is the denoising conventional neural network layers, the representation of the function. This is the noisy picture. We used several layers, and the function used several layers to learn learn more about the noise. Let me present the function. Here is the denoised picture, which Y represent the noisy picture, and this is the learned feature. We learn the feature about the noise, then we substitute it from the noisy picture, so we can get a denoised image. We can see here we have three types of filters: conv plus relu plus conv. This is one type of the layers of DnCNN function. The other type is conv plus bn plus relu, and the last type is conv. So now we will know what is the difference between these three types of layers. Conv plus relu, the size of it is 3 by 3 by c, which is 1 if we have a gray image as we used in this project. This layer consists of 64 filters. We have it only in the first layer. The second layer to D-1, which is the previous before the last layer, we have this type of layers, which is conv plus bn plus relu, which consistent of 64 filters of size 3 by 3 by 64. This 3 represent the pixels. We take a small part of the picture, which is 3 pixels by 3. We use the second type of layer to that's the normalized is added between conventional and draw. The third type of layers we have conv. It's the last layer actually in this function. We used it to reconstruct the output. So then after we learned, after the function learned features about the noise, it will subtract it from the noisy picture. Here is the source. Now we are going to the code. In the code, first I upload the original picture, then I transfer it to gray color, since the function used only in gray color. Here I made a noisy picture from the original picture. I used this function denoise and used Gaussian with 0.01 constant. Here is the original picture, and this is the noisy picture after we used Gaussian noise. After that, I used the DnCNN function to denoise the noisy picture. As we can see here, this is the denoised image. We can compare it to this noisy picture. We can see the difference, but it's not easy to recognize the difference. So I used this function show pair, which is make the difference clearer. Here I compare the original picture with the noisy image. I take the difference. The difference represented as a white dot, white color in this picture. We can see that we can the noise is all over the picture, so I can notice any difference. Here I compare the denoised picture with the original. We can see that is more clearer. Here I use different type of Gaussian noise. Here I used bigger than the one I used before. I used 0.1. We can see that the difference is not good as the previous one. But if I decrease the constant, we will have a better picture, a better difference. Since because that we can conclude that if we have smaller Gaussian, we will have a better representation of this function. In the summary, I used the denoise DnCNN function to denoise the noisy image. The DnCNN uses multiple of neural network to learn feature that help denoising image properly, as we explained previously. The result of the denoising was decent, as shown in the comparison between differences of images. I used my knowledge of data fitting that I learned in numerical methods course to use the right function to denoise images. That's it. This is my project. Thanks.